Good morning. In the last lecture, we have started with the motion curve. What is the motion curve? Here, when a particle is moving along the straight line, during that motion, here for that particular particle, when the acceleration of that particle is plotted against time, velocity plotted against time, and displacement is plotted against time. So this graph obtained are known as the motion curve. Okay. When a particle moves along the straight line and during this motion, if the type of motion of the particle is different in different interval, for example, from A to B, it is moving with a variable acceleration motion. From A to B, it is moving with a B to C, it is moving with a uniform acceleration motion here, and from C to D, it is moving with a deceleration here. So when the acceleration is different in different interval of time, when the particle is having a different type of motion in different interval of time, it is better to solve the sum by using the motion curve instead of using the equation of motion. Here, normally the sum of the motion curve can be solved by using the equation of motion also. Okay, I am going to tell you that concept, how can we solve. Okay, but normally in this AT, VT and ST diagram, we are going to use the property of that motion curve to solve the sum. Now, which are the properties of the motion curve? I told you that the area under AT curve, which are the properties of the AT curve, the area under AT curve in some interval of time, here gives you the change in velocity. Therefore, area under AT curve gives you the change in velocity in that interval of time. Remember once again, the area under AT curve will not give you the instantaneous velocity of a particle at any particular moment. It gives you the change in velocity. Here, and the time at which the acceleration is zero, here, or to be more precise, the time at which the AT curve changes its sign. Here, at that particular time, the velocity will be either maximum or minimum. When the acceleration changes from positive to negative, here the velocity will be maximum. Here, and when the acceleration changes from negative to positive, the velocity will be minimum. Okay, so you have to remember and you have to calculate that maximum and minimum velocity. So these are the two important properties of the AT curve. Then I told you about the VT curve. Which are the important property of the VT curve? Here the two properties are similar. The first one is the area under VT curve in any interval of time. Here gives you the change in displacement, or it gives you the distance traveled by the particle in that interval of time. Here, at the time at which the VT diagram changes its sign, at that time the displacement is maximum and the particle reverses the direction of motion. Here, so when the VT diagram changes its sign, here at that time the displacement is maximum here, and the particle reverses the direction of motion. Then slope of VT diagram represent the acceleration. Here, slope of VT diagram represent the acceleration. Suppose this is the VT diagram. Here, if you calculate the slope of this curve at any particular instant of time t, here, so that slope at that particular time gives you the acceleration of the particle at that particular instant. Okay, so slope of VT diagram represent the acceleration, and for ST diagram, here the property is slope of ST diagram. If it is a slope versus, displacement versus time diagram, and if I calculate the slope of that displacement versus time diagram, that is, it becomes ds by dt. So ds by dt represent the velocity. So these are the properties. Here you have to read all the properties carefully. Here all the theory notes are given to you. Here you have to just read it carefully. Therefore, I am summarizing this property. Very easy to summarize the property. Here, what are that? Here you have to draw all these three figures one below another. Area under AT diagram gives you the change in velocity. Area under VT diagram gives you the change in displacement. Here, slope of ST diagram gives you the velocity. Slope of VT diagram gives you the corresponding acceleration. Here, and the remaining two properties, AT diagram here changes its sign. The velocity will be either minimum or maximum, and the time at which the VT diagram changes its sign, at that time the displacement is maximum or minimum. In that it is the maximum distance away from the origin here, and at that point or at that time the particle reverses the direction of motion. Okay, so these are the important properties which you have to remember. Then I also told you that here most of the time आपको question कैसे आता है? Here any one curve out of that three would have been given, and it may ask to calculate the or to draw the remaining two curves. Okay, here, so I suggested draw all the three curves one below another here on left hand side page and do the corresponding calculation on right side page. Okay, all the three figures you have to draw one below another. Here suppose AT diagram is given, draw the given AT diagram and leave the space for VT and ST diagram. Okay, now we'll solve one question. Okay, the nature of the AT and VT and ST diagram. Here I told that here we got the velocity equation by integrating the equation of acceleration, and when we integrate any equation, here the degree of the equation increases by 1, and that's why from this one we can conclude that the nature of the VT diagram is 1 degree more here than the AT diagram. Means if the AT diagram is having the linear equation, VT diagram will be a quadratic equation. Means if AT diagram is an inclined straight line, corresponding VT diagram will be a parabola. And corresponding ST diagram is again 1 degree more, means that will be a curve of degree 3, that is a cubic curve. Okay, so that you have to remember here while drawing the AT, VT and ST diagram. Here, so we are going to solve the first question. Here, motion curve first question, page number 17. Page number 17, sum number 1. Here AT diagram is given. Actually, the 3 interval are given. Here, आपको एग्जाम में 3 interval का sum नहीं आएगा. It becomes little bit lengthy. Okay. Here, but I am taking here 3 interval sum. This AT diagram is given. It is from 0 to 20 seconds, 20 to 40, and 40 to 50. This is 12 seconds. Sorry, this is 12 meter per second square. This acceleration is in meter per second square and time is in seconds. From 12 to 40, it is horizontal straight line, and 40 to 50, it is decreasing and becomes 0. This AT diagram is given, and you have to plot the corresponding VT diagram, how the velocity will change. You have to plot the VT diagram here, and you have to plot the ST diagram. Okay, so one below another you have to, I will project all these key points. These are the key points, or these are the key times you can say. Why? Because this is the point, or this is the time at which the type of motion varies, or the equation of this curve varies. Here एक ही equation valid नहीं है 0 to 50 second के लिए. 0 to 20 second के लिए the curve is continuous, means the equation is same. Here at 20 seconds the equation will change because the curve is changing. So these are the key points. Here, so you have to mark these key points, and at these key points you have to calculate the value of velocity as well as displacement, and you have to join that point by the suitable curve so that you will get the VT and ST diagram. Okay. Here, so these are the key points where the equation changes, where the curve changes. Here, so at the key points we are going to calculate the value of the velocity, and we'll join them to get the VT diagram. Similarly, at these key points we'll calculate the position of the displacement, and we'll join them to get the ST diagram. Okay. Any doubt? Okay. Now unmute yourself and somebody tell me, can you identify the type of motion from this AT diagram? From 0 to 20, ये जो मोशन है कौन से टाइप का मोशन है? 0 to 20 क्या हो रहा है इधर?
एक्सेलरेशन चेंज हो रहा है सर.
एक्सेलरेशन चेंज हो रहा है, राइट. मतलब कौन से टाइप का मोशन है ये?
Variable acceleration.
We have studied the variable acceleration motion. Means from 0 to 20 here it is a variable acceleration motion, right? And from 20 to 40,
uniform acceleration motion.
It is a uniform acceleration motion. Okay. Yes, so from 20 to 40 it is a uniform acceleration motion. And from 40 to 50,
deceleration.
Deceleration है. Deceleration है. Type of motion कौन सा है? Deceleration मतलब acceleration negative है. Sorry. I made a mistake. Extremely sorry. Let me tell you, आपका आंसर भी है और मैंने भी बोल दिया. Actually 0 to 40 it is not a decelerating motion. ये deceleration नहीं है. Make it clear. 40 to 50 it is not a deceleration. यार deceleration कब आएगा? अगर ये एक्सेलरेशन का मैग्नीट्यूड इसके नीचे जाता है, यार ये एक्स एक्सिस के नीचे जाता है, या तो इसका एक्सेलरेशन निगेटिव आएगा. एम आई राइट? और ये बन गया डिसेलरेशन, ये डिसेलरेशन नहीं है, दिस इज नॉट द डिसेलरेशन, ये पॉजिटिव एक्सेलरेशन ही है। कहीं पे भी देखो एक्सेलरेशन का वैल्यू पॉजिटिव है, इजंट इट? यस, फिर क्या हो रहा है, उसका मैग्नीट्यूड डिक्रीज हो रहा है, वो है पॉजिटिव एक्सेलरेशन ही, ओनली इट्स मैग्नीट्यूड इज वैरीज फ्रॉम +12 to +0, 12 to 0 डिक्रीज हो रहा है, इट इज नॉट अ डिसेलरेशन, मेक इट क्लियर। इज दैट क्लियर? डिसेलरेशन कब होगा, अगर इसके नीचे जाता है कर्व तो ये डिसेलरेशन है, अगर कर्व नीचे जाता है तो वेलोसिटी डिक्रीज होगा, ये एक्स एक्सिस से नीचे जाता है तो, नीचे है तो, व्हाट माय पॉइंट? तो इट इज नॉट अ डिसेलरेशन। नाउ टेल मी 40 to 50 ये दोनों में से कौन से टाइप का मोशन है, वेरिएबल एक्सेलरेशन है या यूनिफॉर्म एक्सेलरेशन है?
Variable.
It is a variable acceleration motion,
Variable acceleration.
It is a variable acceleration motion. मतलब अगर मुझे ये सम सॉल्व करने के लिए टू गेट द वेलोसिटी एंड डिस्प्लेसमेंट, क्लियर, अगर ये सम सॉल्व करने के लिए मुझे 0 to 20, अगर इंस्टेड ऑफ यूजिंग दिस मोशन कर्व, इंस्टेड ऑफ यूजिंग द प्रॉपर्टीज ऑफ द मोशन कर्व, अगर मुझे ये सम इक्वेशन ऑफ मोशन लिख के अगर सॉल्व करने का है, या तो 0 to 20 के लिए अलग इक्वेशन रहेंगे, 20 to 40 के लिए अलग, 40 to 50 के लिए अलग इक्वेशन ऑफ मोशन रहेंगे। क्लियर? सेम इक्वेशन ऑफ मोशन विल नॉट बी वैलिड। हैव यू अंडरस्टूड दिस? यहाँ के लिए वेरिएबल एक्सेलरेशन मोशन का अप्लाई करना पड़ेगा, जो मैंने आपको सिखाया है। क्लियर? लेकिन हमने जो सीखा उसमें क्या दिया था, डायरेक्टली इक्वेशन दिया रहता था और हम उससे वेलोसिटी का इक्वेशन लिखते थे, डिस्प्लेसमेंट का इक्वेशन लिखते थे। ये सब में इंस्टेड ऑफ डायरेक्टली इक्वेशन उसका कर्व दिया है, उसका ग्राफ दिया है, so from the graph we can write down the equation, not that difficult thing, okay? तो हर एक के लिए अलग अलग इक्वेशन लिख के आप सॉल्व कर सकते हैं, one method, और other method we can directly use these properties of the motion curve to solve this, okay? यार ये एक सम में दोनों मेथड से आपको सॉल्व करके दिखाता हूँ, लिटिल बिट टाइम कंज्यूमिंग, क्लियर, मे भी 1 घंटे में एक ही सम होगा, क्लियर, लेकिन आपका 90% कंसेप्ट क्लियर हो जाएगा एक ही सम में, okay? Now, if you want to solve it by using the properties of the motion curve, here, now we are doing the calculation for VT curve. Calculation for VT curve. Now I am doing it little bit fast. Okay. Now calculation for VT curve. Now calculation करते वक्त क्या करने का है, एक एक इंटरवल लेने का है। अब ये इंटरवल कैसे सिलेक्ट करने का है, ये इंटरवल ऐसे सिलेक्ट करने का है कि जिसमें वो मोशन कंटिन्यूअस है, या जिसमें इक्वेशंस ऑफ द मोशंस आर कंटिन्यूअस, ग्राफ कंटिन्यूअस है, ग्राफ चेंज नहीं हो रहा है, ऐसे इंटरवल आपको सिलेक्ट करने का है। मींस यू कैन कंसीडर द इंटरवल फ्रॉम 0 to 20, यार आप 0 to 40 भी ले सकते हैं, नॉट ऐसा नहीं है, लेकिन ये की पॉइंट है जहां पे मोशन स्टार्ट हो रहा है, उधर का मुझे वेलोसिटी चाहिए, इसलिए आई एम गोइंग टू कंसीडर द मोशन फ्रॉम 0 to 20। अगर मुझे वेलोसिटी चाहिए एट t equal to 30, आई कैन कंसीडर द मोशन फ्रॉम 0 to 30 आल्सो, नो इशू, okay? So I am consider motion from 0 to 20 seconds. Consider this interval 0 to 20 seconds. Now we have to do the calculation for VT diagram from AT. Now we know that area under AT diagram gives you the change in velocity, or interval is 0 to 20. Therefore, this change in velocity is represented by the area under AT curve. Now, if I consider the interval 0 to 20, here if I denote the velocity at t equal to 0 is v0 and velocity at t equal to 20 is v20. So what will be the change in velocity in this interval? It becomes v20 final velocity minus initial velocity. This becomes the change in velocity. This change in velocity gives you the area under AT curve. Okay, here it won't be the v20. It is v20 minus v0. So V20 minus V0 is equal to the area under AT diagram from 0 to 20 second interval. ये एरिया चाहिए मुझे, ये कितना होगा ये एरिया?
20.
It is a triangular area. It's a triangular area. Okay. So how much is that? It is half into base. Base is 20 seconds. And how much is the height? Height is 12. So which is equal to 120 meter per second. So this 120 meter per second is what? It is not the velocity at 0 or velocity at 20. Here it is actually the change in velocity in this interval of time. 120 is the change in velocity in this interval of time. Now if I know the velocity at t equal to 0, I can calculate the instantaneous velocity at t equal to 20, isn't it? Yes. So most of the sum में वो velocity at t equal to 0 is given. Clear? But if it is not given, how much is the velocity at t equal to 0? You can use our standard boundary condition what we have used in the variable acceleration motion. अगर बाउंड्री कंडीशन नहीं दिया है तो हम लोग क्या बाउंड्री कंडीशन यूज करते थे कि वी यूज टू अज्यूम दैट एट t equal to 0 पार्टिकल स्टार्ट फ्रॉम रेस्ट एंड फ्रॉम ओरिजिन. ये बाउंड्री कंडीशन हम लोग यूज करते थे ना. तो यहाँ पे भी हम लोग ये बाउंड्री कंडीशन यूज करेंगे टू गेट द वेलोसिटी एट t equal to 20. Here, so let velocity at t equal to 0 is 0. Here I am using this boundary condition. Here if I substitute it here, I will get the velocity at t equal to 20, which is equal to 120 meter per second. Any doubt? Have you understood?
Yes, sir.
Yes, sir.
Now I have considered that the velocity at t equal to 0 is 0. Here and velocity at t equal to 20 मैंने कैलकुलेट किया वो कितना है 120. अप्रोक्सीमेट प्लॉट करने का है, कुछ स्केल लेने का जरूरत नहीं है. Okay, so it is 120. This is 120 meter per second. Velocity at t equal to 20, right? Now to calculate the velocity at t equal to 40, you can consider the interval from 0 to 40. Or since I know the velocity at t equal to 20, I can consider the interval from 20 to 40 also. Here, so consider interval from 20 to 40 seconds. Yes, so we know that the change in velocity in this interval is equal to the area under AT curve. So change in velocity in this interval is v40 minus v20, which is equal to, now how much is the area from 20 to 40, because we have considered that interval only. So how much is this area? Now it is a rectangular area whose base is 20 and height is 12. So it is 20 into 12. It is 240 meter per second. So 240 meter per second is the change in velocity in the next 20 second interval. It is the change in velocity in this 20 second interval. Clear? Now if I know the initial velocity of this interval, I can calculate the final velocity because I know the change in velocity. Here now v20 is known to you, it is 120. If I substitute it here, I will get v40 equal to 360 meter per second. Clear? किसको समझ में नहीं आया बोलो. Unmute yourself and ask your doubt. Have you understood this?
Yes, sir.
सर एक बार फिर से
Okay. हाँ ये देखो मैंने v20 निकाला, इट इज 120 मीटर पर सेकंड. अभी मुझे ये ग्राफ प्लॉट करने के लिए मुझे वेलोसिटी एट t इक्वल टू 40 चाहिए. अभी ये वेलोसिटी एट t इक्वल टू 40 का कैलकुलेट करने के लिए आई एम कंसीडरिंग द इंटरवल फ्रॉम 20 टू 40. मैं 0 टू 40 भी कर सकता हूँ. अगर 0 टू 40 किया तो मुझे ये पूरा एरिया लेना पड़ेगा. यस, but since I know the velocity at t equal to 20, I am going to consider the interval from 20 to 40. ये इंटरवल कंसीडर किया मैंने. अभी what we know here, area under AT diagram we know from 20 to 40, and area under AT diagram gives you the change in velocity. So change in velocity in this interval becomes v40 minus v20 here, which is equal to the area under AT diagram. Now what is the area under AT diagram from 20 to 40 second interval? ये इतना एरिया है, वो कितना है ये 20 into height is 12, so it is 240. So this 240 is the change in velocity in this 20 second of interval. Okay, yeah, now to get the instantaneous velocity at t equal to 40, ये at t equal to 40 ये velocity 240 नहीं है, ये डायरेक्टली इधर मत लिखो. Actually this 240 is the change in velocity in this 20 second interval. Now if I know the velocity at t equal to 20 at the beginning of that interval, I can calculate the v40. अभी v20 तो हम लोग को पता है, it is 120 meter per second. So if I substitute that here, I will get the velocity at t equal to 40 equal to 360. यार समझ में आया क्या? So approximately you have to plot 360.
Yes, sir.
Doubt है क्या? Have understood?
Yes, sir.
Okay.
Yes, sir.
Now I have to calculate the velocity at t equal to 50. अभी velocity at t equal to 50 calculate करने का है, तो I have to consider the interval from 40 to 50 because I know the velocity at t equal to 40. Okay, so consider कौन सा interval? 40 to 50. Okay, same formula. Change in velocity equal to the area under AT curve. Okay, now how much is the change in velocity from 40 to 50? So it is v50 minus v40 equal to, how much is the area under AT diagram from 40 to 50? ये triangular area कितना है वो? It is half into base is 10 into height is 12. So which is equal to 60 meter per second. So 60 meter per second is the change in velocity in the last 10 seconds. Last के 10 सेकंड में कितना वेलोसिटी चेंज हुआ? So it is 60 meter per second. Understood?
Yes, sir.
Yes, sir.
Now to plot this graph, I want the instantaneous velocity at t equal to 50. That I can get if I know the v40, and that I know. v40 is 360. So let's substitute that. So I'll get v50 equal to, it is 60 plus 360, which is equal to 420 meter per second. This is the velocity at t equal to 50. Any doubt? देखो सेम रिपीटेशन है, खाली बस 3 इंटरवल दिया है, तीनों इंटरवल में वो रिपीटेशन है, सेम प्रोसीजर है. क्या समझ में नहीं आया बोलो? Because it is not possible to take the number of sums. Okay, concept clear कर लो. You can apply that concept in any sum. Tell me, any doubt? Now we have to plot. Yeah, so at t equal to 20, velocity is 120. At t equal to 40, velocity is 360, and t equal to 50, the velocity is 420. I have plotted the point. Here now I have to join all these points by the proper curve. Proper curve use करने का है. Here approximately curve draw करने का है, but we have to draw the proper curve. Understood? Now unmute yourself and answer my question. From 0 to 20. क्लियर, ये 2 पॉइंट मुझे फ्रॉम 0 टू 20 VT डायग्राम के ये 2 पॉइंट मुझे पता है. एट t इक्वल टू 0 वेलोसिटी 0, एट t इक्वल टू 20 वेलोसिटी इज 120. क्लियर, और ये 2 पॉइंट मुझे ज्वाइन करने का है बाय यूजिंग द प्रॉपर कर्व. क्लियर, अभी फ्रॉम 80 डायग्राम अगर 0 टू 20 में अगर इंक्लाइन स्ट्रेट लाइन है, 80 डायग्राम इज इंक्लाइन स्ट्रेट लाइन, इफ द एक्सेलरेशन वैरीज लीनियरली. क्लियर, व्हाट विल बी द नेचर ऑफ द VT डायग्राम? VT डायग्राम का नेचर क्या आएगा?
पैराबोलिक होगा सर.
पैराबोला.
It will be a parabola. 1 degree curve. Sorry, 1 degree.
Degree increases by 1.
ये डिग्री इज इंक्रीज बाय 1. अगर ये इंक्लाइन स्ट्रेट लाइन है तो ये पैराबोला आएगा. राइट? एम आई राइट?
Yes, sir.
Okay.
Yes,
Now
sir.
listen. From 0 to 20, I know only 2 points on that curve. Here, and from the 2 points, I can draw only straight line. To draw any type of curve, here whether it is a parabola, cubic curve, concave or convex, any type of curve, at least 3 points are required. Here through the 2 points we can draw only straight line. और कौन सा भी curve plot करने के लिए minimum 3 point का जरूरत रहता है. Okay, so that if you require that third point, you can calculate at t equal, considering one additional point t equal to 10, and we are considering the 0 to 10 second interval, आपको velocity at t equal to 10 भी मिल जाएगा, मिल सकता है अगर ऐसा ही सेम कैलकुलेशन 0 to 10 सेकंड के लिए किया तो. ओके क्लियर, बट व्हाट आई एम सजेस्टिंग, नो नीड टू डू दिस. क्लियर, ये 2 पॉइंट में से ही हम लोग अप्रोक्सीमेट पैराबोला ड्रॉ करेंगे. हम लोगों को एग्जैक्टली ड्रॉ करने की जरूरत नहीं है. वी हैव टू ड्रॉ अप्रोक्सीमेट पैराबोला. Okay, now through these 2 points only we will draw approximate parabola. Now when I will draw the approximate parabola through these 2 points, yeah, 0 to 20, sorry, 0 and 120. So these 2 points I have to draw approximate parabola. Okay, only question will be whether that parabola will be a concave upward or convex upward. Concave आएगा या convex आएगा?
कॉनकेव आएगा सर.
क्या बोल रहे हैं
सर? कॉनकेव है.
कॉनकेव आएगा.
कॉनकेव आएगा. कॉनकेव मतलब ये आएगा, राइट?
यस सर.
ओके, व्हाई?
एक्सेलरेशन बढ़ रहा है ना इसलिए.
एक्सेलरेशन बढ़ रहा है इसलिए. एनी अदर मींस यू आर राइट यार, बट कैन यू इलैबोरेट मोर समथिंग? व्हाई? एक्सेलरेशन बढ़ रहा है तो इधर भी वेलोसिटी बढ़ रहा है ना, इसमें भी वेलोसिटी बढ़ रहा है, इसमें भी वेलोसिटी
सर
बढ़
उसका
रहा है.
स्लोप बढ़ रहा है ना सर. कॉनकेव पैराबोला का स्लोप बढ़ रहा है तो
Right.
स्लोप बढ़ रहा है मतलब एक्सेलरेशन बढ़ रहा है.
हाँ हाँ, राइट. ये देखो अभी, नाउ टू डिसाइड whether it is a concave or convex, to decide whether it is a concave or convex, okay, here we know that we are plotting the VT diagram. Now we know that the slope of VT diagram represent the acceleration. Okay, here slope of VT diagram represent the acceleration. Now from 0 to 20, what happens with the magnitude of the acceleration? Acceleration का magnitude क्या हो रहा है? Acceleration का magnitude बढ़ रहा है. Acceleration is increasing. Now from 0 to 20, since the acceleration is increasing, it means that we have to plot such a VT diagram whose slope should increase. We have to draw such a VT diagram whose slope should increase. Now, out of these two diagrams, here the slope of this concave curve is increasing. इसका slope increase हो रहा है. Here it becomes vertical. So slope is increasing. Whereas this becomes horizontal. So इसका slope decrease हो रहा है. We know that the slope of the curve is equal to the slope of the tangent. Here और ये convex अगर plot करता हूँ, तो this becomes horizontal. Okay. Here horizontal curve हो रहा है, मतलब slope 0 की तरफ जा रहा है. Okay. Here the slope is increasing. Here so from 0 to 20. Since the acceleration is increasing, so we have to plot such a VT diagram whose slope should go on increase. Okay, so approximate plot करने का है from 0 to 20, such a curve whose slope is increasing. Whose slope is increasing. Clear? And approximate plot करो and write down here that is P, means parabola. Okay, clear? Any doubt? Understood this? So it is a concave parabola. अभी देखो ये ST डायग्राम कैलकुलेट करने के लिए हम लोगों को इसके इधर का एरिया लेने का है, एरिया अंडर दिस पैराबोला लेने का है. यार अभी आपने अगर ये कर्व रॉन्ग कर दिया तो एरिया अंडर दिस पैराबोला एंड एरिया अंडर दिस पैराबोला here will be different even though the end points are same. Okay, so you have to be more careful. Any doubt? Now from 0 to 24, same concept you have to now apply in the remaining interval. Here ये सबको समझ में आया क्या? Okay. Now 20 to 40. Now we have to join these 2 points, 120 and 360. Now from 20 to 40, the AT diagram is a horizontal straight line. If AT diagram is a horizontal straight line, here the corresponding VT diagram will be 1 degree more. अगर ये horizontal straight line है तो ये inclined straight line आएगा, right? Here now 40 to 50. It is an inclined straight line. अभी AT diagram inclined straight line है तो ये parabola आएगा. Again between the 2 points only we have to draw the approximate parabola. Again same question. Convex आएगा या concave आएगा? Here same
convex.
Same logic. Now from 40 to 50 the acceleration magnitude is decreasing. Acceleration का magnitude decrease हो रहा है. मतलब मुझे ऐसा VT diagram plot कर दिखा है कि जिसका slope decrease होना चाहिए. Here, so out of these two curves, here this convex is the curve whose slope is decreasing, right? Any difficulty? So this is the required VT diagram. This is also the parabola. Understood? Any doubt? Now next, calculation for ST diagram. Okay. Now to do the calculation for ST diagram, we know that the area under VT diagram gives you the change in displacement. If you have to use the area under VT diagram, and in VT diagram there is a parabola. So we have to calculate the area under parabola. Now how to calculate the area under parabola? Now what direct formula is also available to calculate the area under any curve if you know the degree of that curve. And another method, if you know the equation of that curve. If you know the equation of that curve, then by integrating that equation from 0 to 20, you can get the area under that curve. Am I right? If you have studied in mathematics, here agar iska equation pata hai, so if I integrate that equation from 0 to 20, I will get the area under that curve. Here then that becomes again tedious method. You have to write down the equation and then you have to integrate that to get the area. Here, so instead of that, we are going to use the direct formula to calculate the area under the parabolic curve. I am going to tell you the direct formula how to calculate the area under parabola. Yeah, just remember, you can write it in your upper margin of your book. How to calculate the area under a parabola. Here, if I consider this parabola. Parabola means it is the curve of degree 2. Okay, here similar equation can be written for the parabola for degree 3. Formula is little bit different. Okay, now I am not going in deep. Okay, so just remember how to calculate the area under the parabola. Now to calculate the area under parabola from this limit to this limit, what you have to do? From this point to this point, you have to inscribe that parabola in a rectangle. Here, ये parabola को rectangle में inscribe करो. Inscribe that parabola in the rectangle. Here, so if the dimension of that rectangle A is A by B, A into B, here, then this smaller part of the area between the rectangle and the parabola is 1/3 of the area of the rectangle. ये कितना रहता है? In case of parabola only I am talking. अगर cubic curve है तो formula अलग है. Okay, so only for parabola, only for the equation of degree 2, this smaller area is 1/3 of the area of rectangle, and this bigger area is the 2/3 of the area of rectangle. This you have to remember. Here, area under parabola. Area under parabola. 1/3 of the area of rectangle and 2/3 of the area rectangle. Here, अगर ऐसे parabola आता है, so you have to insert that parabola in a rectangle. Here, so these become 1/3 and these become 2/3. Okay, जो साइड कॉन्केव है उधर का एरिया 2/3, कॉन्वेक्स है उधर का एरिया 1/3. Okay, so you have to remember this formula, write it in your book at proper place. Now, calculation for H3 diagram. I put this. Calculation for H3 diagram. Consider the interval 0 to 10. Sorry, 0 to 20 seconds. Same interval you have to consider. Because at the same point, 3 points, you have to calculate the displacement and you have to join that by the proper curve. Now 0 to 20. Now we know that here this change in displacement is represented by the area under ZT diagram. Okay, now change in displacement in this interval, let it is S20 minus S0. S20 is the displacement at t equal to 20, S0 is the displacement at t equal to 0, which is equal to area under ZT diagram. Now let's consider the interval from 0 to 20 and let's calculate the area under this ZT curve from 0 to 20. मतलब I have to calculate this area. Now just now what I said, क्या करने का, how to calculate the area under ZT diagram. तो ये parabola है. So from this point to this point, here inside that parabola in a rectangle. So I inside that parabola in a rectangle. So this area is a smaller area, which will be the 1/3 of that area of the rectangle, isn't it? So it is 1/3 of area of the rectangle. How much is the area of rectangle? It is 20 by 120. Okay, which is equal to 800 meter. Yeah, this 800 meter is the distance traveled by the particle from 0 to 20 seconds. This 800 meter is the change in displacement from 0 to 20 seconds. And you will observe that here from 0 to 20 seconds, the velocity is positive. Velocity negative नहीं हुआ. Velocity का direction, sorry, particle का motion का direction change नहीं हुआ. So it is the same direction. That's why it is a positive. Here, and if the velocity is positive, it does not change its sign. Here, in that case, we can conclude that the particle is moving in the same direction. उसने उसका direction of motion reverse किया ही नहीं. अगर direction of motion reverse करता है तो velocity become negative. Okay, velocity positive मतलब वो एक ही direction में move हो रहा है. And when the particle is moving in the same direction, then the displacement is equal to the distance traveled. So we can say that if the particle starts from rest, then this will be the displacement, or sorry, change in displacement from 0 to 20 seconds, or you can say that it is the distance traveled by the particle in 20 seconds, 0 to 20 seconds. Understood? Now मुझे displacement time graph plot करने का है, distance versus time नहीं. Yeah. Now for that we want a displacement at t equal to 20. ये होगा change in displacement. Okay. Now to calculate the displacement at t equal to 20, I should know this S0. Now nothing is given about the S0. S0 is the displacement at t equal to 0. It means that it is the initial displacement which is not given. Okay, and I already told you that here is the displacement, initial displacement is not given. Let us assume the standard boundary condition. Let us assume the particle start from origin. Or let us assume the point from where the particle start, that point itself as origin, so that the initial displacement becomes 0. Okay, so I am considering that here let S0 equal to 0. Substitute in this one. So you will get S20 equal to 800 meter. Understood this? This is the displacement at t equal to 20. Okay. Now consider the next interval. Same procedure you have to repeat for the 3 intervals. Now consider 20 to 40. Consider 20 to 40 second interval. So it is S40 minus S20, which is known to you, which is equal to the area under ZT diagram. Now from 20 to 40, the VT diagram is the inclined straight line. So you have to consider this area, this total area. Now it is a trapezoidal area. If you know the formula to calculate the area of this trapezium, you can use it directly. If not, let's split it into two parts. Rectangle plus triangle. So how much is the area of this rectangle? It is 20 into 120. This is 20 into this is 120. So this becomes the area of this rectangle plus how much is the area of this triangle? So it is plus half into base of the triangle. How much is the base? It is 20. Into how much is the height of the triangle? Triangle का height ये कितना होगा? It is 360 minus 120. It is 240. Clear? So how much is this? It is 2400 plus it is 2400, which is equal to 4800. So this much is the distance traveled by the particle from 20 to 40 seconds. Or you can say that this is a change in displacement from 20 to 40 seconds. Here, since I know the S20, here by using that I can get the absolute position of the particle at t equal to 40, which is equal to 4800 plus 800. So which is equal to 5600 meter is the displacement at t equal to 40. Any doubt? Now same procedure you have to repeat for the last 10 seconds to calculate the displacement at t equal to 50. Here I am writing directly. Here, so for next interval S50 minus S40 equal to the area under VT curve. So it is S50 minus S40 पता है. It is 5600, which is equal to. Now how much is the area under VT diagram? ये VT diagram is parabola है. What is the area under this VT diagram from 40 to 50 seconds? ये area चाहिए मुझे पूरा area. So to calculate this area, I will split it into two parts. Area of this rectangle plus area under this convex curve. To calculate the area under this convex curve, ये area calculate करने के लिए what I am going to do? Let inside this parabola inner rectangle. ये rectangle में include कर लिया. अभी मुझे ये area चाहिए. Now it is a area of the figure here towards the concave part. So this becomes the 2/3 of the area of the rectangle. Am I right? It is 2/3. Just remember that earlier figure. It is 2/3 of the area of the rectangle. Here, so let's first calculate the area of this bigger rectangle. So how much is that? 10 into 360. Base is 10 and height is 360. So it becomes the area of this rectangle. Plus how you are going to calculate this smaller area under this curve? Okay, into how much is this width? It is 10. So if you calculate this, it is 3600 and it is 4,000. So 3600 and 20. $4,000. Am I right? Correct आ रहा 360 into 10 correct है plus 2/3 of 60 into 10 correct है क्या?
Yes, sir.
ये 400 आएगा not 4,000.
Yes, sir. Yes, sir.
Okay.
460.
Total 4,000. Total 4,000 meter. करेक्ट है क्या? कैलकुलेशन करो. यूज योर कैलकुलेटर.
सर वो एरिया अंडर स्मॉलर कर्व बताना फिर से.
एरिया अंडर द कर्व.
स्मॉलर कर्व. हाँ.
ये देखो एरिया अंडर पैराबोला अगर कैलकुलेट करने का, सपोज मुझे यहाँ से यहाँ तक का एरिया कैलकुलेट करने का इसके नीचे का. ओके, तो यार क्या करने का है, वो पैराबोला को रेक्टेंगल में इंस्क्राइब करने का. मतलब ये कॉर्नर से हॉरिजॉन्टल एंड वर्टिकल लाइन ड्रॉ करो और रेक्टेंगल कंप्लीट करो. क्या ये रेक्टेंगल कंप्लीट? ओके, यार अभी ये रेक्टेंगल का अगर बेस ए है और हाइट अगर बी है, तो एरिया अंडर दिस कर्व, यार ये पार्ट जो है बिटवीन द रेक्टेंगल एंड दिस कर्व इज 2/3 ऑफ द एरिया ऑफ रेक्टेंगल रहता है. जो बिगर एरिया है वो, और वो स्मॉलर एरिया रहता है ये 1/3 इंटू एरिया ऑफ रेक्टेंगल ऐसा रहता है. अभी इधर से यहाँ तक मैंने इंस्क्राइब किया उसको, तो ये एरिया बन गया 2/3 ऑफ द एरिया ऑफ रेक्टेंगल, और प्लस ये एरिया बिकॉज आई हैव टू कैलकुलेट द टोटल एरिया अंडर दैट कर्व। समझ में आया क्या?
हाँ सर।
Okay. Now this is the change in displacement from 50 to, sorry, this is 5600. This is a change in displacement from 40 to 50 seconds. Here, then how will be the displacement at t equal to 50? So it is 4000 plus 5600, it is 9600 meter. This is the displacement at t equal to 50 seconds. Right है क्या? Any difficulty?
No, sir.
Okay. So this is the displacement at t equal to 50. Now I have calculated the position or displacement at major points. I have calculated the displacement at t equal to 20, t equal to 40, and t equal to 50. Now let's plot. Okay, at t equal to 0, displacement is 0. Is it visible to you? ये visible है क्या?
Yes, sir.
Okay. At t equal to 0, displacement is 0. At t equal to 20, displacement is 800. ये देखो, स्केल लेने का जरूरत नहीं है, अप्रोक्सीमेट प्लॉट करो, थोड़ा प्रोपोर्शनेट प्लॉट करो, दैट्स ऑल. ओके, सो एट t equal to 20 displacement is 800, at t equal to 40 displacement is 5600, and at t equal to 50 the displacement is 9600. Okay, any doubt? Have understood this? (800, 5600, 9600). Now we have to plot, join this point by the proper curve. Now from 0 to 20, it is a parabola. VT diagram is a parabola. अगर VT parabola है तो ये क्या आएगा? 1 डिग्री ज्यादा, मतलब कौन सा कर्व आएगा? इधर क्यूबिक कर्व आएगा. Actually there is no difference between the parabola and the cubic curve. ये सेम ही रहते हैं. ओके यार, ओनली अगर इसका इक्वेशन लिखा तो वो डिग्री 2 में आएगा, इसका इक्वेशन लिखा तो डिग्री 3 में आएगा. दैट इज ओनली द डिफरेंस. यार जस्ट बाय नेकेड आइज नोबडी इज गोइंग टू कंक्लूड. अगर मैंने ऐसा कर्व प्लॉट किया है यार, और मैंने पूछा बताओ ये पैराबोला है या क्यूबिक कर्व है. ओके, सो विदाउट knowing any equation or without knowing any parameters we can't say that whether it is a parabola or cubic curve. ओके यार, उसके लिए उसका इक्वेशन ही लिखना पड़ेगा यार. तो यहाँ से हम लोगों को अप्रोक्सीमेट क्यूबिक कर्व प्लॉट करने का है. ओके, नाउ द सेम क्वेश्चन, दो ही पॉइंट है, तो दोनों पॉइंट में से कैसे प्लॉट करने का क्यूबिक कर्व. क्वेश्चन वही है कि वो कॉन्वेक्स ड्रॉ करेंगे या कॉनकेव ड्रॉ करेंगे यार. तो अगेन सेम concept. Now we are plotting the ST diagram and we know that the slope of ST diagram represents the velocity. Now from 0 to 20, the velocity is increasing. Just cross check the magnitude. Velocity is increasing. Now since the velocity is increasing from 0 to 20, इसका मतलब मुझे ऐसा ST diagram plot करने का है कि जिसका slope increase होना चाहिए. So this is the curve whose slope is increasing. This is not. Okay, so this is the ST diagram. या और ये कर्व कौन सा है? क्यूबिक है, तो इधर सिर्फ सी लिखो बस. क्यूबिक कर्व, क्यूबिक लिखा तो भी चलेगा, ओनली सी लिखा तो भी चलेगा. इट्स अ क्यूबिक कर्व. नाउ फ्रॉम 20 टू 40 इट इज इंक्लाइन स्ट्रेट लाइन. अगर ये इंक्लाइन स्ट्रेट लाइन है तो दिस विल बी अ पैराबोला. ओके, नाउ अगेन हियर द वेलोसिटी इज इंक्रीजिंग, सो आई हैव टू ड्रॉ अ पैराबोला. उसको शुड गो ऑन इंक्रीज, तो ऐसा ही आएगा, बट इट इज अ पैराबोला. नाउ फ्रॉम 40 टू 50 इट इज अ पैराबोला, सो इट विल बी अ क्यूबिक कर्व. क्लियर? नाउ अभी यहाँ पे क्यूबिक कर्व कैसे आएगा? यार कॉन्वेक्स आएगा या कॉनकेव आएगा? यार तो अगेन कॉन्वेक्स आएगा या कॉनकेव आएगा? नंबर 1 आएगा या नंबर 2 आएगा? नंबर 1 इज
नंबर 1.
नंबर 2.
नंबर 2 आएगा. हाँ लिसन, इधर देखो मैंने क्या बोला आपको. वी आर प्लॉटिंग द ST डायग्राम. Yes, so I told that the slope of ST diagram represents the velocity. Now just observe 0 to 40. What happens with the magnitude of the velocity? Velocity का magnitude क्या हो रहा है 40 to 50 के बीच में?
डिक्रीज
डिक्रीज हो रहा है क्या? इधर
इंक्रीज हो रहा है,
इधर 420 है.
इंक्रीज हो रहा है.
इंक्रीज हो रहा है
ना? इंक्रीज हो रहा है ना वेलोसिटी का मैग्नीट्यूड, या डिक्रीज हो रहा है?
इंक्रीज हो रहा है सर.
इंक्रीज हो रहा है. किसी ने तो भी डिक्रीज हो रहा है बोल रहा था. Okay, so just observe 360 है 420 है, clear? So velocity is increasing. यार ऐसा मत देखो कि ये कब ऐसा ऐसा हुआ मतलब velocity डिक्रीज हुआ, ये कब ऐसा क्यों आया यार, ये कब इसलिए ऐसा आया कि velocity is increasing, लेकिन the rate, listen carefully यार, ये 40 to 50 में क्या हो रहा है, velocity is increasing but the rate at which that velocity is increasing, that rate is decreasing. यार मैंने पहले बोला ये डिसेलरेशन नहीं है, ये एक्सेलरेशन ही है, ये पॉजिटिव एक्सेलरेशन ही है। सिर्फ क्या हो रहा है 40 to 50 के बीच में, वो एक्सेलरेशन का मैग्नीट्यूड डिक्रीज हो रहा है, पॉजिटिव ही है लेकिन उसका मैग्नीट्यूड डिक्रीज हो रहा है। व्हाट डज इट मीन? इट मीन्स दैट द रेट एट व्हिच दैट वेलोसिटी इज इंक्रीजिंग, दैट रेट इज डिक्रीजिंग। क्लियर? लेकिन वेलोसिटी इंक्रीज ही हो रहा है, सो जस्ट यू हैव टू ऑब्जर्व द मैग्नीट्यूड। यार इतना सोचने का जरूरत भी नहीं है, just observe the magnitude. So velocity is increasing, so you have to plot such a graph, ST diagram, whose slope should goes on increase. Here, so one number curve is the correct curve. Here, this is the curve whose slope is increasing because the velocity is increasing. Here, and this is the cubic curve. Here, now this is the end of this sum. Here, just tell me any difficulty. इतना बड़ा सम नहीं आएगा, okay? यार अभी एग्जाम में क्या क्वेश्चन आ सकता है, एग्जाम में क्या क्वेश्चन आ सकता है, ये देखो एटी डायग्राम दिया रहेगा, ये 3 पार्ट लिया है ना, 3 में से कोई भी 2 ले सकते हैं, दिस एंड दिस शॉर्ट करने के लिए, ओके? नहीं तो क्या ले सकते हैं, दिस एंड दिस, ओके? नहीं तो क्या कर सकते हैं, फर्स्ट एंड थर्ड। यार एक ही सम में से 3 सम बना सकते हैं। Understood? Yeah, same procedure you have to follow. Yeah, can you solve that? 3 sums? Okay, sum number 3 देखो कैसा है, sum number 3 which is given in that book. सम नंबर 3 में क्या है, पहले वेलोसिटी एक्सेलरेशन डिक्रीज हो रहा है, ये पार्ट पहले आया, फिर एक्सेलरेशन इंक्रीज हो रहा है, फिर ये पार्ट आया, और फिर एक्सेलरेशन कांस्टेंट है, ओके? फिर ये पार्ट आया। एक्चुअली दिस इज एग्जाम क्वेश्चन, लिटिल बिट लेंगे, अगर ऐसा क्वेश्चन आता है तो 6 से 8 मार्क्स के लिए आएगा, ओके? यार लेकिन आप ये प्रैक्टिस करो और किसी भी 2 पार्ट ज्वाइन करके यू डू द प्रैक्टिस। एनी डाउट?
नो सर।
अभी देखो, अभी इसमें से ये हमने मोशन कर्व का कंसेप्ट यूज करके सॉल्व किया, यार बट फर्स्ट टाइप ऑफ कंसेप्ट कैन बी यूज ओनली फॉर एटी, वीटी एंड एसटी डायग्राम। यार अगर एक्सेलरेशन वर्सेस डिस्प्लेसमेंट का अगर डायग्राम दिया है तो दिस प्रॉपर्टीज आर नॉट एप्लीकेबल फॉर दैट। अगर एक्सेलरेशन वर्सेस डिस्प्लेसमेंट या तो एक्सेलरेशन वर्सेस वेलोसिटी का ग्राफ दिया है तो दैट दिस कंसेप्ट्स आर नॉट एप्लीकेबल फॉर दैट, ओके? तो अगर वैसा ग्राफ दिया है अदर देन एटी, वीटी एंड एसटी अगर डायग्राम दिया है तो वो कैसे सॉल्व करने का, ओके? क्लियर? मेथड 2 क्लियर, एप्लीकेबल फॉर एनी ग्राफ, कुछ भी रहने दो, एटी रहने दो, एएफ रहने दो, एवी रहने दो, कोई भी ग्राफ रहने दो, दिस इज एप्लीकेबल। इसमें क्या करने का, इसमें यार इन दिस सेकंड मेथड में यार राइट इक्वेशन ऑफ ग्राफ इन ईच इंटरवल एंड सो ऑन, ओके? इक्वेशन लिखने का और उसको सॉल्व करते जाने का। Here now I am considering the motion from 0 to 20 seconds. I am considering 80 diagram only, 0 to 20 seconds. अभी 0 to 20 सेकेंड अगर आपने 80 डायग्राम देखा तो ये इंक्लाइन स्ट्रेट लाइन है, इट इज इंक्लाइन स्ट्रेट लाइन। कैन यू राइट डाउन द इक्वेशन ऑफ दिस स्ट्रेट लाइन? यार लिखा ना मैंने इधर, राइट द इक्वेशन ऑफ द ग्राफ। So can you write down the equation of that straight line from 0 to 20 seconds? बताओ फटाफट। What will be the
Yes, sir.
equation? क्या आएगा इक्वेशन?
2 पॉइंट फॉर्म से आएगा सर.
2 पॉइंट फॉर्म से आएगा. क्यों स्लोप इंटरसेप्ट फॉर्म नहीं आ सकता है?
हाँ वो भी आ सकते हैं.
वो भी आ सकता है, राइट. बट यू शुड नो बोथ. 2 पॉइंट फॉर्म भी पता रहना चाहिए, स्लोप इंटरसेप्ट फॉर्म भी पता रहना चाहिए. ओके यार, y इक्वल टू mx प्लस c. y एक्सिस पे एक्सेलरेशन है, स्लोप इज 12 अपॉन डेल्टा y अपॉन डेल्टा x. तो डेल्टा y इज 12, डेल्टा x इज 20. On x axis it is t plus c is the y intercept. How much is the y intercept for this line? It is 0. For this line the y intercept is 0, isn't it? Yeah. So this equation becomes a equal to 0.6t. This is the equation of this graph. समझ में आया क्या? y equal to mx plus c में c क्या रहता है? It is the y intercept of that straight line. Okay. यार अभी ये 80 का ग्राफ आ गया, सॉरी इक्वेशन आ गया है. अभी अगर मुझे 80 का इक्वेशन पता है तो क्या है? राइट डाउन द इक्वेशन ऑफ vt. यार तो इसको इंटीग्रेट करेंगे टू राइट डाउन द इक्वेशन ऑफ vt. So it is dv by dt equal to 0.6t. That is dv equal to 0.6t dt. Integrating both sides. So v equal to 0.6t square upon 2 plus constant of integration, let it is c1. Yeah. And since the boundary conditions are not known, so I will consider let at t equal to 0, v equal to 0. If I substitute, c1 is also equal to 0. अगर इसमें substitute करता हूँ तो here if I substitute and write down the equation, so I will get v equal to 0.3t square. This is the equation of this vt curve. ये vt curve का वो equation आ गया है. ये equation से भी मैं बोल सकता हूँ कि this will be a parabola. It is a second degree equation. Understood? Here now we at अभी मुझे I want to calculate the velocity at t equal to 20. So at t equal to 20, if I substitute, so v equal to 0.3 into 20 square. 20 square is 400. 400 into 0.3. How much? It is 120 meter per second. This is the velocity at t equal to 20. Understood? Yeah. Now I know the velocity at t equal to 0 is 0. If I substitute t equal to 0. Okay. मतलब ये 2 पॉइंट मुझे मिल गए. Yeah. Similarly for st diagram. यार ये पता है v equal to 0.3t square. Yeah. Now from this one to write down the equation of displacement, you have to integrate it with respect to t. ds by dt. So it is the integration of v. It is ds by dt. So integration of ds equal to 0.3t square into dt. Integrating. So s equal to 0.3 into t raised to power cube upon 3 plus constant of integration c2. Here we know that at t equal to 0, s equal to 0, so c2 0 ही आएगा. So equation becomes s equal to 0.1 t cube. This is the equation of this st curve. ये curve जो है उसका वो equation है. Then at t equal to 0, s equal to 0. And at t equal to 20, s equal to, it is 20 cube into 0.1. So 20 cube is how much? 8,000. 20 into 20 into 20, 8,000. 8,000 into 0.1, 800. So at t equal to 20, s equal to 800. Clear? So mark these 2 points and join this curve. Means by writing the equation, you have to analyze this, each part separately. इसका AT का इक्वेशन लिखो, उससे VT का लिखो, उससे ST का लिखो, और from that equation get the magnitude of that displacement and velocity at that particular point and plot the curve. Yes, so 0 to 20 का interval complete हो गया. Then go for the 20 to 40 interval. Here write down the equation of AT. Here for 20 to 40 में क्या इक्वेशन आएगा? AT का वो horizontal straight line है जिसका slope 0 रहता है. Slope 0 है मतलब y equal to c. Here मतलब a equal to 12. This is the equation of this acceleration. Okay. Here so from this one I can write down dv by dt is equal to 12. That is dv equal to 12 into dt. If I integrate this, I will get v equal to 12t plus c1 c2 कुछ भी लिखो. Then I know that at, okay, this is the equation of the VT डायग्राम फॉर द नेक्स्ट इंटरवल 20 to 40 के लिए इक्वेशन है वो। नाउ आंसर माय क्वेश्चन। यहां तक समझ में आया क्या आपको? हैव अंडरस्टूड दिस? क्या कर रहा हूं मैं, समझ में आया क्या आपको?
यस सर।
एक ही स्टूडेंट को समझ में आया? देयर आर 50 अदर स्टूडेंट्स।
Yes, sir, समझा।
49। ओके, अभी देखो ये इक्वेशन में ये C1 कैलकुलेट करने के लिए मैंने ये बाउंड्री कंडीशन सब्स्टिट्यूट किया था at t equal to 0, v equal to 0. Can I use this boundary condition here to calculate this constant and to get the equation, generalized equation? Can I use t equal to 0, v equal to 0 here?
No, sir.
Why not? Why not?
वो लाइन ओरिजिन से पास नहीं हो रहा सर।
कौन सा लाइन?
No, sir. They are different curves.
यस सर।
कौन से कर्व डिफरेंट है?
सर इधर इनिशियल
From-
टाइम तो 20 सेकंड्स
You
होगा
mean
ना?
to say that this curve is different and मतलब this curve is different and this curve is different? ऐसा बोल
No,
रहे
sir.
क्या?
Boundaries are different. No, sir. Boundaries are different. From 0 to 20, the
हाँ.
boundaries are different. From 20 to
Yes,
40,
yes,
the boundaries are different.
Okay, for this equation the boundaries are different, for that equation boundaries are different, for this is boundary conditions are different, that is boundary conditions are different. Or in a simple word, this equation is valid, ये जो equation लिखा पहले वाला, this equation is valid only from 0 to 20. ये सिर्फ इसके लिए ही valid है, ये boundary के लिए ही valid है. Similarly, this equation is valid only for this boundary. Understood? And that's why for this equation, to calculate this constant, I can't use the other boundary conditions. Apart from this, I can't use the boundary conditions. Here, and that's why in this equation, to find out that C2, here I should know the known value of the velocity at the known time t in this region only, because this equation is valid in this region. And that I know. क्या पता है आपको? At t equal to 20, the velocity is how much? You have calculated 120.
120.
Here, substitute here. So it is 120 equal to 12 into 20 plus C2. So how much is the C2? 120 minus 240, that is C2 equal to minus 120, isn't it? So equation becomes V equal to 12t minus 120. This is the equation of the VT curve from 20 to 40. You will observe that this is a linear equation, मतलब it will be inclined straight line. अभी ये इक्वेशन में in this boundary, ये जो boundary है 20 to 40 का, इसमें I am going to calculate the value of the velocity to plot this curve. Understood? Here, अभी ये boundary में at t equal to 20, I know that the velocity is 120. ये पहले ही पता है. And at t equal to 40, substitute t equal to 40 in this equation, you will get the corresponding velocity. If I substitute t equal to 40, so 12 for the 48. So it is 480 minus 120. Therefore, 480 minus 120 is 360. This is the velocity of the particle at t equal to 40. आपको वही आंसर आएगा. Understood? Concept समझ में आ रहा है क्या आपको?
Yes, sir.
यस सर।
Okay.
यस सर।
So this method you have to use for any other graph. अगर आपको acceleration versus displacement diagram दिया है, तो आप ये property apply नहीं कर सकते. क्लियर? तो एक्सेलरेशन वर्सेस डिस्प्लेसमेंट अगर ग्राफ दिया है तो आपको उसका इक्वेशन ही लिखना पड़ेगा. और वेरिएबल एक्सेलरेशन का जो कंसेप्ट मैंने पढ़ाया आपको कि अगर कोई इक्वेशन दिया है तो उसे दूसरा कैसे इक्वेशन लिखने का है, क्लियर? बाय यूजिंग दैट कंसेप्ट यू हैव टू राइट डाउन द अदर इक्वेशन एंड यू हैव टू सॉल्व. क्लियर? समझ में आया क्या? हैव अंडरस्टूड दिस?
यस सर।
Okay.
Yes,
Here,
sir.
now this is the motion curve. Here, we'll wind up this motion curve here only. Here, if you have any doubt, you can ask me. Solve few more sums. Yes. Concept तो सब clear हो गया. एक भी concept बाकी नहीं है. Okay. Clear? In the next lecture, we are going to start the curvilinear motion. Okay. आपका जो एग्जाम है, जो कमिंग एग्जाम, आपको टाइम टेबल मिला क्या?
तो
कौन से डेट पे कौन सा एग्जाम है वो नहीं पता सर।
वो नहीं सर पता।
क्या? कौन सी डेट को?
टाइम टेबल नहीं मिला है सर।
टाइम टेबल नहीं मिला, शेड्यूल तो मिला है ना. शेड्यूल कल मैंने आपके ग्रुप
Sir,
पे एक जस्ट 1 minute, आई वांट जस्ट 2 minutes, आई विल स्टॉप द रिकॉर्डिंग एंड आई विल डिस्कस समथिंग विथ यू. in 2 minutes only.